The aim of this experiment is to determine the equivalent resistance of two resistors when connected in series. The material required to perform this experiment is an ammeter, a voltmeter, one-way plug key, a low resistance rheostat, connecting wires, battery eliminator, sandpaper, and two unknown resistors. So set up the circuit as shown in this diagram. Connect the two resistors in series and the voltmeter should be connected in parallel with respect to the two resistors. Then in the remaining part of the circuit, connect an ammeter, a battery eliminator, a one-way switch and a rheostat in series. Be very careful about the positive and negative terminals of your apparatus and connect it according to the diagram shown here with the help of connecting wires. So once set up, your apparatus would look something like this. So the two resistors in series. In parallel, you have a voltmeter, then in series, ammeter, a battery, switch and a rheostat. Let us now perform the experiment. For finding out the resistance when resistors are connected in series, we have taken two resistors here, 10 ohms each. So this is the first resistor and this is our second resistor, and you can see that they have been connected in series. And we have connected a voltmeter which is in parallel with the resistors. And then in the main circuit we have a rheostat using which we can control the amount of resistance. We have an ammeter which will tell us the current that is flowing through the circuit, and we have a battery eliminator which will be the source of current for our experiment. Now when we change the position of the rheostat, we find a deflection in the needles of the ammeter and the voltmeter. So for now, if I place the rheostat at this particular position, you can see that the reading in the ammeter corresponds to the 8th division. So this is our first set of readings. Now if I change the settings of the rheostat, you can see the deflection in the needles taking place. You can note down the second set of readings, and likewise you can take third, fourth and any number of readings using this apparatus. So this is how we verify that when the resistors are connected in series, then the net resistance of the circuit is the sum of the individual resistors. Let's now fill in the observations that we made. So when we performed the experiment, before performing the experiment, we checked for the range of the ammeter, and the range of the ammeter was 0 to 1 ampere. The least count on the ammeter was 0.02 ampere. There was no zero error and hence no correction required. Similarly, the range of the voltmeter was 0 to 5 volts and the least count here was 0.1 volt. Again, there was no zero error and hence no zero correction is required. Then for the set of observations that we made, when the reading in the voltmeter was 1 volt, the reading in the ammeter showed 0.05 ampere. Then the reading, when we changed it to 2 volts, the reading in the ammeter turned 0.1 ampere, and when the reading in the voltmeter was 3 volt, the reading in the ammeter showed 0.15 ampere. Now when we calculate the ratio V by I for these three readings, we get 20 ohms for each of these. That means the mean value of resistance that we have used when connected in series is 20 ohms. So since we already knew that the resistors that we used were of 10 ohms each, and according to the rule which says that the resistance, the net resistance in series is the sum of the resistors when they are connected in series connection, you just have to add them up. So 10 plus 10, experimental value is 20 ohms, but the actual value also is 20 ohms. So the conclusion that we can draw here is that the calculated and the value obtained by the experiment are almost the same, and hence this rule, resistance in series is the sum of the individual resistors, is verified.